What is 2D gel electrophoresis? 2D gel electrophoresis is a powerful method for analyzing complex protein mixtures. This technique allows the simultaneous separation of thousands of proteins from biological samples. It combines two powerful separation methods. 1. Isoelectric focusing, IEF. 2. SDS-PAGE, sodium dodecyl sulfate polyacrylamide gel electrophoresis. 2D gel electrophoresis separates proteins in two main steps. Isoelectric focusing, IEF separates proteins by their isoelectric points, pi. Proteins migrate through a pH gradient until they reach a region matching their pi, achieving high-resolution separation with focused protein bands. SDS-PAGE separates proteins by molecular weight, MW. Sodium dodecyl sulfate, SDS, denatures proteins and imparts a uniform negative charge. Proteins are then separated by size during electrophoresis in a polyacrylamide gel. Steps in 2D gel electrophoresis. Sample preparation. Isoelectric focusing, first dimension. SDS-PAGE, second dimension. Visualization of protein spots. Identification of protein spots. 1. Sample preparation. Preparation involves breaking of non-covalent interactions. Using reagents like urea, SHAPS, tris base, and DTT. Removing interfering substances. To ensure the purity of protein samples and preventing protein degradation. By adding protease inhibitors. 2. Isoelectric focusing, first dimension. Steps. Establish a pH gradient in the gel. Proteins migrate to the pH that matches their pi. Proteins stop moving when they reach their pi, no net charge. Isoelectric focusing, IEF, separates proteins based on their isoelectric point, pi, the pH at which a protein carries no net charge. During IEF, proteins migrate in a pH gradient until they reach the pH corresponding to their pi and focus at that point. This technique utilizes immobilized pH gradients, IPGs, or ampholytes to create the pH gradient. Proteins remain focused and do not move further once they reach their respective pi. This step is crucial for resolving proteins that differ by as little as 0.01 pH units, providing high-resolution separation in the first dimension before further separation by SDS-PAGE in the second dimension. 3. SDS-PAGE, second dimension. Steps. Proteins are coated with SDS, giving them a uniform negative charge. Apply an electric field to the gel. Proteins migrate through the gel, smaller proteins move faster than larger ones. Proteins are coated with SDS, which denatures them and imparts a uniform negative charge. Migration through the gel matrix is driven by an electric field. Separation is based on molecular weight, with smaller proteins moving faster through the gel. Process. SDS binds to proteins, giving them a uniform charge-to-mass ratio. The gel is placed in an electric field, causing proteins to migrate. Polyacrylamide gel acts as a sieve, allowing smaller proteins to travel further than larger ones. 4. Detection/visualization. Includes staining techniques. Koumassi stain. Silver stain. Fluorescent stains, e.g., cypro-ruby. Detection methods. Phosphoimager. Fluoroimager. After separation, proteins must be detected to analyze the results. Common staining methods include Koumassi blue, known for its ease of use and adequate sensitivity, and silver stain, which offers higher sensitivity but is more complex. Fluorescent stains are increasingly popular due to their high sensitivity and capability for multiplexing, which allows for the simultaneous detection of multiple proteins. Accurate visualization is crucial for subsequent analysis, such as mass spectrometry, to identify and quantify proteins in the sample. 5. Protein identification. Includes mass spectrometry, MS. Peptide mass fingerprinting, PMF. Tandem MS, MS/MS. Database searching. Mass spectrometry, MS technique used to measure the mass-to-charge ratio of
Peptide mass fingerprinting, PMF, an analytical technique for protein identification where the unknown protein is digested into peptides, and their masses are measured and compared to databases.
Tandem MS involves multiple rounds of mass spectrometry, typically used for sequencing peptides by fragmenting them and analyzing the resultant fragments. Database searching utilizes software to match MS data to known protein sequences in databases, facilitating identification based on peptide or fragment patterns.